Okay, I will keep it short as possible. Always shoot questions at me if you have some. It's going into the direction where we left. It's about building AI infrastructures and what we might have already learned from other things where we build infrastructure. I'm Michael, CTO and co-founder of Rethink. And yeah, let's look into it. We will use some terms. I will introduce maybe a new term, maybe not. We use cloud native. It's almost 12 years old. The concept, I guess, of those curves is known. It's from Crossing the Chasm. It's a book. And if it's about technology adoption, if something crosses the chasm between early adopters and early maturity, it's considered, yeah, it is here to stay. And it will basically just move on, and yeah, well, there will be adoption. If you look at cloud native nowadays, I guess we're somewhere here. Not a lot of new stuff is happening, of course, new tools and more stable stuff, but at the end, it's boring. It's boring, it's commoditized. Been there, seen that, and not a lot of companies start now their cloud native journey. The next one is already starting. It's called AI native. It's not just bigger because I'm a bad graphic designer. It's considered economically bigger. Economically means there's just a bigger total addressable market, more money is in it because it's also applicable outside of IT and software development. That also means we need to build stuff that actually can support the higher demand, and that's what we are going to talk about. So how to build proper infrastructure that can handle AI workload. It's not about which fancy model you want to use or code assistants or agents. It's really about how to build AI models. There was the term. There are similarities already. At the beginning, at least, the CNCF said cloud native is about containerization, dynamic orchestration, and microservices. So it was more an architectural pattern. There is no foundation yet, and I hope it stays like this, because if you look at the CNCF nowadays, it's not as nice anymore. But if we look, why is it that? Oh yeah, you can see the left. AI native is not an architectural pattern. It's more like, hey, you enhance some stuff in your application, you put it at the center. Your unit is a model or an agent, something like that. And it's about model performance, data flow, data optimization. It's more about throughput rather than scalability and maybe uptime. At the end, the biggest difference is it's in AI, it's about state. In cloud native, it was about stateless. At the end, the stuff we are then doing is kind of the same. You will find Kubernetes, vector databases, and other things that you might have heard or seen in similar forms. If you look at platforms, no matter if they are AI platforms or cloud platforms, maybe I should have said I have run a cloud consultancy for 10 years and sold it and now do this. So we have seen all kinds of platforms and they're all shit. Usually they're all shit. Of course, there's Kubernetes, there's all kinds of things, but at the end what you find is the left part. Yes, the left. You have all the things, of course it's a car, but it's not usable. And that's what you find when someone is building a platform, mainly internal teams. There's all the things, and then here's a Git repo, do your shit. We are doing GitOps, but take care of the user experience by yourself. Platform engineering is product engineering, so you should have a product owner or of some sort, and someone that takes care that the stuff you are building is actually usable. And it doesn't matter if it's data scientists or developers, but you should build for them. What you need is the right, whether it's a Golf 2 or not, that doesn't matter. But at the end, what you want, hand out a key, go for it. Yeah, mine too. But I stole it from my brother all the time, so it was not mine. So it's a product you are building, but that's not the case. And that's where we're going now. We look at a blueprint and a customer case, and then hopefully I will speed up a bit so that we won't be in time, but close enough. You will find in a AI platform things you will also see. It's all about enabling, in that case, a data scientist. Normally it's a developer, it doesn't matter. It's about scaffolding or golden paths for your developers. So you have all the things there. You will find special things like a feature store, a data store such as databases. Often you will find vector databases, but you still find Postgres all over the place and other things. You will find model registries. Well, in your cloud native infrastructure, you also find quite often Harbor or something like that for images. Here you have a model. You have pipelines. You abstract away compute, Kubernetes and other things. Then serving runtimes. I think he mentioned inference. There are also tools for just doing that. And observability. Here it's not just about how much CPU, memory, whatever else, but it's also about model performance, degradation of a new model, what features went into whatever model you have built, which which data, which versions, all that, and then you can compare different models, the performance of the different models, why your new model is worse than the previous one, those kind of things. So that's what's meant here. And then, at least in certain industries, automated governance, like checking for bias, all other things. There are tools for that in AI, so that whatever you are building adheres to whatever governance you have in place. On the architecture side of things, it's also not that far away from what we have at cloud native architecture. We can consider this a microservice architecture. You have split up concerns. It's called a FTI pipeline architecture, feature, training, and inference split out. So it's not the usual ML, batch processing, whatever else. So you split it up. You have a feature pipeline where data comes in, and then you create features and labels and store them in the feature store. The next service, which is your training pipeline, takes the features and labels, does its thing, creates a model, stores the model. And then you have an inference pipeline where the model and the features are basically taken, and then inference is done to whatever, end users or machines or whatever else. The nice thing about it is you usually have stable interfaces between them, so you can change things independently from each other. And if you have a big enough team or demand, you could have different teams dealing with it. As you see, there are quite some tools involved here and there. So you could basically have dedicated team for feature pipeline, training pipeline, inference pipeline, and maybe as well for the storages. That helps to create a quite stable architecture. And with the blueprint, like abstracting away and how it might look like, we are looking into a customer case. Can't name the company though, but doesn't matter. It's a big automotive company, Asian. They acquired a company in the US, and they had autonomous driving already in place. So they have 13 cars driving in California, which means they have kind of working product. They got acquired because the company wants to offer at one point autonomous driving to their customers. So they bought them. They knew whatever they have is shit. So it's intended, if you build something new, and especially as a startup, what you are doing is validate your stuff, get it out, and well, doesn't matter how you scale it. Scale is from now. So they got acquired, and now it's about, well, how does a platform look like? How can we operate a platform? What principles we put in place? All of that. The goal was basically quite simple. They want to operationalize on it. So basically scale it out, get it into their big machine, in their big enterprise. But what we made out of it is like helping the data scientists to not manage all the platform and put self-service for them in place. That's kind of it. They run, or already did run on Google. They spent roughly 35 million on that infrastructure on GKE. They have, I can't count how many NVIDIA H100 GPUs attached to the thing. And yeah, that's what they do. They gather basically data from car, which is vision, LiDAR, radar, and whatever other sensors you might imagine, cameras, whatever else, and then do things with it. They had for each of this data stream, more or less, it's not exactly it, you see, I've stolen it, but it's kind of a typical batch processing pipeline. Each data scientist did their own thing. They didn't reuse a lot of stuff from the others, and it took a lot of time. That's why they spent 35 million on the infrastructure for 12 cars, just to train a model, or models. They did train models, but what happened quite often is as well, someone did something on the cluster, and it broke the whole training process of another one, which could have run already since months. So not that effective. So they had, of course, quite some challenges. Scalability is just one of them, but mainly it's about it's just waste. It was just wasted, and they couldn't utilize the clusters properly because everyone was just scaling stuff up. But if you looked at the graphs, well, they had an average utilization of 25%, but they couldn't do more. So yeah, that's what we did. We helped them, used whatever we had, and started to really work certain things. So we introduced this FTI pipeline and used something called the strangler pattern. You might have heard from Martin Fowler. It's about usually if you go from a monolithic application to a microservice application, how to basically strangle your monolith. You can do the same thing here. You take out one part of a pipeline and replace it with something else in a new architecture or in a new thing, and then just root through that bit and do this over and over again until basically there is only the one thing, which was the FTI. There was already Kubernetes in place, but no infra as code, or no proper infra as code, so that was also something we had to do. I hope that we also would build models, because we are all kind of as well data scientists by heart. No, that they have in place. They didn't need really help on how to build vision models. I've never done it, so I would have liked to do it, but no, we built that. So it's about setting up the tools and tie them together. You mentioned already Jupyter and notebooks. They also use that. Pachyderm, Kubeflow, Argo, well-known tool. And then K-Serve for the inference bit. So they went with that because it's not an LLM. It's just like for testing, they use K-Serve. But at the end, it goes on the car. There is no Kubernetes cluster on the car. This is really just for building the models and doing testing and stuff with it. At the end, it goes to a car. Something I really hate, Backstage. They had Backstage already in place. They also have a quite huge platform for all the other things within the enterprise, which is also a Kubernetes platform running on EKS. And there they have a Backstage team, and they kind of forced us to use Backstage. Whoever you use Backstage knows potentially the pain that comes with it. It's not that flexible. It's super hard, in my opinion, to set up or change something. If you want to change, you need to rebuild the application. Application is written in Node.js. Yeah, what can you do? But here we are. Backstage as a front end was required, kind of. We tied everything together. We helped them with new processes, with guardrails, all that things. But at the end, there was Backstage. I skipped before I started already quite some, so we go straight to the almost end. What did we achieve by basically using platform engineering principles? We looked self-service, so a data scientist can now go to Backstage, fill in some forms or add some stuff, and can just create a new training run, can have access to features, to labels, to models, to whatever else, and can just use them for their own experiment. We also reduced significantly so far the cost by 35%. We are still not 100% done with that. We are aiming for almost 50%. 50% out of 35 is 17 million saved. That will partly go as a reinvestment into a platform team. Yes?
Maybe I missed something, but I don't know, this scenario looks like there are data scientists that want to operate on the platform, but
Yeah.
they don't know how to do it,
Yeah.
and they start building infrastructure.
Yeah.
From my standpoint, as an architect, an engineer, why not suggesting maybe a data platform tool? I know that maybe it's your business to build it, but why not saying, okay, let's use Databricks. Let's not build
Because Databricks is shit.
Oh, sorry?
Databricks is not the best tool on earth, but it's
I agree.
but it's only a data tool. But what they basically have is they need to build proper models, not just
Yeah,
wrangling
models,
data.
there will be a cluster for you. Okay, I'm not saying maybe jump on whatever model, but for all the data scientist tools, why not using, I don't know, Databricks, or if you don't like Databricks, it could be whatever other, I don't know.
Maybe on top, they are like us. We only touch open source software.
Maybe, okay, yeah, that's what I'm saying. I know that maybe it goes against your business, no? But it could be like parallel thinking in a way, say, there is so much to do right now that maybe for you it's better to adopt something like Databricks, and then we can pivot, because you're missing the knowledge to work on that, you're missing, and then we have to...
Yeah, that's why we built the platform, because
Yeah.
we abstracted that away. They have now a team in place that manages whatever has been built. Going forward, there is enough money saved, so they can definitely afford further evolving whatever there is. They have the same philosophy, that's why I guess it's a match. We only touch open source software. And they had big pieces already here and there in place. It was basically just tie them properly together, automate stuff, put guardrails in place. We didn't reinvent the wheel. So they had Kubernetes here, they had certain things already in place and certain things had to be changed, but the tool stack in general, we basically abstracted away so that they can do their things now. You can, of course, always buy a tool, but then you're bound by whatever that is.
You know, like from my standpoint would be, you're just data scientists. I mean, no offense taken.
Oh,
They do their job. But that's the thing, if you don't know how to use all these services and you want to build something from scratch, either they hiring you and then they do everything.
But that's not how startups work. So they've been a startup. A startup doesn't work like I go and buy now a 500k Databricks license. First, there's no case for it. Second, where's the money coming? Money should come from. So they went ahead, did things, built things. There is someone hired that knows now this tool and the next tool, and that's how those stuff work. And then they got to the market. If you are at the Databricks level, usually this is now would be maybe a discussion within the enterprise, but not if you start and build a company. In my company, I would never go out and the first thing I'm doing is now I go on a shopping trip and pay license fees to someone that at the moment doesn't bring any value to me. I can use open source, learn the stuff, do things with it.
I mean, I agree with you, but yeah, okay.
Model development was faster, 25% so far, from basically taking data set in to putting it onto a test environment, so a virtual car basically, which is a virtual one, not a real one so far. The time to deployment, that is basically going to a car is reduced. There has been no baseline in the past. Now there is baseline, but so far it's just plateaued because we haven't done a lot on that bit. They had that kind of well in place. Compliance, as you might imagine, it's a car driving without a driver. It's even in the US regulated. They had certain checks in place, a lot of manual stuff, Excel sheets, whatever. We put something we could call continuous compliance in place, where it's possible we automated things, or we put guardrails in place, in code or in config. There is also audit trail and all things now in place, stored away. all good. So that's what you said. They can now focus on their core competencies. They can build models. They like it. They didn't like managing Kubernetes. So now they can build vision models and whatever else. They are faster. They can now easier use stuff from the others that hasn't been really possible before, except they could talk with each other. They haven't had a central feature store or whatever. It was not properly labeled, properly versioned. That's now just there. Collaboration, that's what I meant. It's not like the human interactions. It was really about interacting on like a software developer would, on the code, with pull requests, with whatever else, comments. And scalability and agility, faster stuff. At the end, start small, as I've said, take certain things out, replace them, make them better, build a platform, and prevent using backstage. That took us more or less, most of the time was backstage. The whole other things that is easy, that was quite easily achievable. Backstage was a pain in the ass.
Do you know any alternative to backstage?
You don't need something. You don't need a UI. Even the best UX, you can still provide either a quite simple UI that you can easily hack together, or you really do your job and abstracting it, you can build a CLI. That is, even a data scientist can use a CLI. Also, a data scientist can put something in Markdown if you want, and then just do a pull request, and then you have your automation in place, something like that. Backstage is quite a fucking beast. Yeah, questions?